Hi everyone, welcome to ITS workshop. In next video series, we'll be talking about MapReduce programming model. So as we already know that when we are studying Hadoop, there are two most important things. First thing is SDFS, Hadoop Distributed File System, and second thing is Hadoop's unique MapReduce programming model. So we are into analytics, and there are various methods of performing analysis on data set, and we'll see how traditional approach is different from the Hadoop approach. And let us see what's this. So in this video we'll be discussing the introductory part of MapReduce programming. First the introduction, little bit history, and then the comparison between traditional versus MapReduce approach in analytics, and then MapReduce model, what it is that with example, and logical data flow of two use cases. First, weather dataset, and second, word count dataset. And then we'll see a couple of examples of advantages of using MapReduce application. So first of all, what is MapReduce programming model? So MapReduce is a model for processing large amount of data in parallel. And that's so we have Hadoop means we have SDFS, and we are doing analysis on large data set. So the Hadoop acquires this model for programming in parallel, and it uses commodity hardware, and it uses a lot of nodes. So it's not just one powerful big machine. We are having multiple machines. Those are just commodity hardwares. And it's connecting through all machine, and it's doing programming using that. Derived from functional programming. So in MapReduce, the most important thing is your map and reduce function. So in map function, we are overriding map function and reduce function, and we are providing our own logic for processing data set. So we have certain data set, and we want to analyze the data set in different manner. So we'll be developing map and reduce functions for that. And this MapReduce programming model is very interesting, and it can be implemented in multiple languages. Like in our examples, we'll be using Java languages, but you can use C++, Ruby, Python, etc. And Java and Python, these are the most popular languages for analytics. So let us discuss a little bit history about MapReduce programming. So in 2004, like Google released MapReduce paper, and then in 2006, Lucen's sub-project was Hadoop, and then 2008, Apache top-level project, which was capable of doing fastest sort of terabytes of data. And in 2012, there is a standard release for MapReduce 2.0 and Yarn. So we'll see in next video series, we'll see what is different between traditional MapReduce programming and what is the advantage of using Yarn, which is also known as MapReduce 2.0. And next, let us discuss why should I use MapReduce. Why not just writing traditional Unix script or some other programming function that will be solving my problem? Why using MapReduce? So there are some challenges with this approach. First, it is not suitable for larger sets. So even if you can give your logic for doing your calculation and providing your logic in one script, you can do that, and you can schedule that script. Those scripts are running, and those scripts are giving you particular result, but those scripts are not useful for larger set. Like your data is getting generated at megabytes and at gigabytes. So what are you going to do that in that case? And it takes more time, since you can use one machine, you can use one powerful machine, but still there is always a time limit. Like I'm telling from my own experience that general script, and which is processing data, and it takes 42 minutes. So 42 minutes, even if it is not that large amount of data, but still 42 minutes is too much, and you would like to reduce this time. And you cannot scale up with production. So in production, your data is getting increased, and from morning to evening, from night to morning, again 24/7 cycle, you want to analyze your data, which is very large. So you cannot just scale up. There will be always one machine, and there will always be a limited amount of time. Let it be 10 minutes, 20 minutes, 30 minutes, 40 minutes, like that, but there will be time limit. And you have, after some limits, you have no control on program to reduce that time amount and to increase your data set. You cannot do that. So that's why the solution comes in our mind is parallel processing. So what is parallel processing? Now the idea is very simple. Let us discuss theoretically what is parallel processing. Like dividing the work into equal size piece chunks. So you have large amount of work, and you are dividing that work into smaller pieces, and you are distributing that pieces, assigning each chunk to a process, and then combining the result from all independent process. So now you can see in red mark I have given the solution. So it is very easy to discuss theoretically that, oh, you have a big task, so divide into a smaller task and distribute that to each process and then combine the result back. It's very simple. But in reality, implementing it requires a lot of challenges. So Hadoop framework comes with all these capabilities. And you see, if you talk about dividing the work into equal size pieces chunk, then HBase is there, which takes care of this. Then your requirement is assigning each chunk to a process. So you have a mapper class, you have a reducer class. So those mapper and reducer are assigning your task, and particular mapper and reducer is a task, your map function, that is one task for your system. And then you want to combine the result from all those processes. Then you have combiner, and ultimately you can give the result. So all these things are taken care by Hadoop framework. And then the processing capacity of a single machine is limited. Obviously, single machine is limited, but in Hadoop case we have n number of nodes. People are using 1,000 machines and 1,000 machine in production, and that's very large set. You can handle GB's capacity of data to, running your application 24/7 model. So who runs the overall job? How do we deal with paired processes? Those are other challenges with parallel programming. So these are also taken care by Hadoop framework. That there should be someone who is taking care of overall jobs. So we have name node, and how do we deal with paired processes? So Hadoop is very good at fault tolerance. Obviously there will be some nodes which will be showing you failure, and Hadoop can handle that situation also. We'll see how these are working, but just to understand what is our requirement and what are the limitations. Then what is MapReduce? How can we define MapReduce? So MapReduce is just breaking the process into two phases, the map phase and the reduce phase. Each phase has a key value pair as input and output, the types chosen by the programmer. So each phase has key value pair as input. So in map phase we have got our own data set. Like you can see, map function will be taking key 1, value 1. So key can be anything, and it can be defined by programmer. So the programmer also specifies two functions, the map function and reduce function. Now MapReduce programming model imposes key value input output. So whatever data set you have got, you need to define what should be the key. So the key can be defined by programmer, and it can vary from one map function to other map function. And for a particular key, we are generating particular value. So map function will be taking, according to this key, it will generate a particular value like k1 v1, and then it is giving you some intermediate result which is k2 v2. Now reduce function is taking this intermediate result according to key k2. It is performing reduction, like summing up all the value 2, and it is giving you k3 v3. So map function is applied to every input key value pair. So there are two phases, map and reduce phases. The map will be your first phase. So you have particular data set, you are applying map function to that. Then you have some intermediate result, then you are applying reduce function with that. And obviously there are some intermediate process like sorting and combining, and all those things are happening, but we'll discuss those things in detail. The simplest model can be defined only in two processes, map and reduce. Map function generates intermediate key value pairs. Intermediate key value pairs are sorted and grouped by key. Reduce is applied to these sorted and grouped intermediate key values. Then reduce emits the final result key values. So that's how we are doing analysis. Like in this diagram, you can see a typical example of any map reduce function. So this is some input, like this is some weather set of data, and according to some day, weather labs are there, they are collecting weather data for each second, each minute, you can say. So for a particular day in a year, you want to get the maximum temperature reached at some particular area. So you are collecting that data, and now I want to perform some analysis. I can ask you some question like in which year, on which day the temperature was maximum. So like for example in 2017, you can say for May 27th the temperature reached at maximum level. This is very simple analytical question. That can be multiple question. So we'll be having data in this format, like some numerical format, and in it can be different, like .csv file or just pipe separated file. It can be different format, and we want to perform some analysis on maximum temperature for a particular day. So first of all, we are applying map function for this. So map function will be taking this, like for 9050 the temperature 0, 9050 temperature 22, 9050 minus 11, 9040 111, 9040. So there will be multiple entries for 9050, there will be multiple entries for 1949, there will be multiple entries for 1948, and so on. Now this all temperature for 9040 is getting listed out. So in shuffle and sort stages it is getting listed out. So for 9040, let us say we have some temperature set 11178. For 9050 we have some set 0, 22, minus 11. That is per day data, and it can for 9050 in real data set it will be for 364 days. And then reduce function is giving us final data. Like in this example, I think they are calculating maximum. So for 9049, some 111 Fahrenheit, for 1950 22 Fahrenheit, like that. So that's how they are calculating. And now in output you may ask according to particular century, according to for like particular year on day wise. So this will be your final output, that okay, for 1949 we got 111 as highest temperature reached, and for 9050 we got 22 as highest temperature reached. So this is typical example for weather data set, and here it looks very simple theoretically, and it looks you may feel like, why do we need MapReduce for this? It can be done using general Unix script. Yes, it can be done. Your calculation can be done for general Unix script, for smaller data set and for some larger amount of time, and there will always be some limitation. But think about the scenario where we are generating data in megabytes, like those space laboratories and those real weather data set, and they have put they are calculating not only weather but so many other pollution information and various information for a particular reason. So that sort of data is getting increased day by day, and so in that particular use case, when data is large enough and you want your analysis quickly, there will obviously not be only a single question for just to get maximum out of a year. Obviously not. There can be hundreds of questions for analysis. So in that case, your MapReduce programming will be useful. When you need some complex analysis, you need quick result, and you have larger data set for calculation. So the next example is you can understand for word count, like you have some scan copy of some novel, or you have some text file, and now you want to have particular word count. Okay, that this particular word, Mr. Some fantasy, so there is fantasy word, so how many times this fantasy word is appearing in this particular data set, or in this particular novel, or in this particular text file. So that is word count scenario. We are counting number of words for a particular text file. So we have got our text file, and now MapReduce breaks text into lines, feeding each line into map function. So it will take line offset. So map function is taking your line offset, so one line at a time, your map function. And map function is particular task, so they obviously, according to your nodes, there will be n number of tasks. So your map function is your text file is divided into line, and particular line, one line can be handled by one task. Now key will be m and value, for say key will be m and value is 1. So here the value is just a mark, just we are putting a tag on it. So like for a word starting with m, we are putting some tag. For a word starting with f, we are just putting one tag. Value is just 1, it's not the real number 1, it's not going to count this 1 1 1. We are just putting tag on it. And in this scenario, for a word a, we are putting tag 1. For key f, we are putting 1. Or I can say any word which is starting from a small f, like fantasy. So as soon as it sees fantasy, it put 1. It see future, again it put 1, like that. So we are just scanning this line, and we are taking each word, and if it is starting from m, we are putting just value 1, and we are tagging it with value 1. Now MapReduce, shuffle and sort. So these are intermediary stages, and they'll do shuffling and sorting and grouping according to output. So all group of f words, all group of g words, all group of m words, all group of o words, like that. So there can be let us see this line. So key m, for key m, it means value 4. It means there are 4 words which are starting from m. So it says like that. So shuffle sort, we get this intermediate result. Now reduce function is the simpler one. It just says counts all these values. So for key m, it just gives the count. Yes, we have 4 words. So map function is simply tagging that particular word, that for m word this one, and for o word this one, and reduce function is just giving you the final count for it. So that's it, and the end result will be having a list with all alphabets. For a word we have 10 number of words, for b we have some 15, for c we have 14 words, like that. So that can be one result set. Now MapReduce framework has got some advantages. It takes care of distributed processing and coordination. So for distributed processing you don't need to worry about anything, how one node will be establishing contact with other node, how will I be dividing my task for one node. So these all will be taken care of by MapReduce framework. You are just writing your logic and you are focusing on your logic part, that oh, this will be my map function and this will be my reduce function, and later we'll see how to write combiner and other stuff also. And you can schedule your job. So jobs are broken down into smaller chunks called tasks, and these tasks are scheduled. So like particular map function, particular reduce function, and that can be scheduled. So you have a streamline of data and you are scheduling your job and you are getting your continuous result set. Then task localization with data. So framework strives to place tasks on the nodes that host the segment of data to be processed by the specific task. Code is moved to where the data is residing. So first of all we are just uploading our data to SDFS node. Then we are just running our MapReduce application. We are not moving data to code, we are moving code to data. That's how MapReduce works. And then error handling. Obviously failures are an expected behavior, so tasks are automatically retried on another machine. So for a particular node the task is getting failed, so that particular task will not be skipped, it will be tried by another node. That's the best advantage working with Hadoop and MapReduce. Data synchronization. So the shuffle and sort barrier rearranges and move data between machines. So it rearranges all your intermediate result, and then it synchronize result from all intermediate results. So input and output are combined by the framework. So you don't need to worry about like from which machine how much output should I take. You don't need to think about that. The shuffle, sort, and this reduction, this framework will take care for that. So for more information you can read this book. It's very nice, Hadoop the Definitive Guide, and you can take your notes and understanding from this. So thank you for watching this video, and in next video series we'll be totally devoting our time for MapReduce programming model with practical examples, and we'll be developing our programs and we'll be running our MapReduce on single node and on multiple nodes also. So thanks a lot. If you like this video, please click on subscribe button and please click on like button, and thanks a lot.